Hello, this is Jack at Jack's Transmissions. Today we're going to talk about the KAPS all-wheel drive controller. This is becoming a pretty common toy that people will install in their GTR, and it can be very useful, but if you use the maps that it comes with, it can actually kill the car and not allow it to perform in the manner that everyone intends it to. So what I'm hoping here is to do like a KAPS course 101 here, just to make some basic changes so people get an idea of what to do with these things and get them to work properly for your application. The first feature this has is it has 4 different maps to choose from. It comes with 4 maps in it already, and the way you change the maps is you go down here to your transmission switch, you push it down twice, and you go into map switching mode. If you watch your torque split gauge, I'm on map 2, it's map 3, map 4, down to map 1, and so on. So that's how you switch maps. Now, one thing about this controller is the maps that they have installed, from the manufacturer, is very conservative. They're trying to be very careful so they don't have people installing this and wrecking the shit out of their car. I would imagine is the reason for this. Essentially, the way this system works is, the way the ETS system works, and what makes the R35 so amazing is, the R35 is a rear-wheel drive car with front-wheel assist. So the ETS system is a series of clutches that'll engage and transfer power to the front wheels when needed. It's very reactive. So, at low speed conditions where you have high load, it's gonna, the ETS clutches are gonna clamp down, transfer more power to the front to help you move you along like an all-wheel drive car. And when you get up to speed and you no longer need that, it'll pull power away from the front and get you more and more rear wheel biased as you accelerate. So what's really nice about this is you don't have the drivetrain loss you see in a lot of all-wheel drive cars at speed. You have the advantages of an all-wheel drive car off the line and at low speed conditions or through an apex of a turn at the track, and then you have no drivetrain loss that you normally see in an all-wheel drive car when you're actually at speed. So it's really awesome. The KAPS controller, the way this is set up from the manufacturer, is the maps that they give you is very, very conservative. So instead of pulling power away from the front wheels as you accelerate, it keeps it clamped. It keeps the ETS at full clamp load all the way through. So the main complaint I get from these KAPS all-wheel drive controllers is the trap speed at the drag strip goes way down. If somebody puts this in there, runs it at map 4, which everybody recommends, you take off, your 60 foot's not bad, you'll find that your trap speed just plummets. You'll be down a few miles an hour. And that's because the system is not letting go as you accelerate, and you have drivetrain loss as you gain speed, and it kills mile per hour. So if we go back to this, so we talk about my car a little bit. My car is full bolt-on. It has NT01 tires on it, and they're the staggered tires. So it's really, the KAPS controller can really be your friend if you use it correctly. And what's really nice about a KAPS controller is you can program all of this stuff yourself. So with my NT01 tires, they're notorious for being a different diameter, front and rear. And if you program this right, you won't burn up your tires, you won't burn up your ETS, and you'll actually get better performance out of this than you would the factory system. So let's go to a factory map here, which is map 4. I left that one in there so you can see it. So when we look at this, we have kilometers an hour this way, and this is throttle position down this way. Now if you're a dumb American like me and you don't understand kilometers an hour very well, what I did on my car is obviously mile per hour here. I changed this to show kilometers an hour so I get used to it. So if I'm doing 65 miles an hour, it'll show 100 kilometers an hour here. So I get more of a feel as to what I'm looking at here when I'm playing with the KAPS software, because it only shows this in kilometers an hour. So we'll look at the map here that it comes with. At 100% throttle, the ETS is at 100% clamp load all the way through to as fast as you can go. This is totally wasted energy, especially at higher speeds right here. if it's at 100% clamp load, you're burning up your tires, you're burning up the clutches in the ETS, and you're killing your trap speed. This is not how you want it to be, and everyone runs them this way. It's very safe, but it's also killing you as far as performance is concerned. Now my car, since it's very weak and it's full bolt-on and I have sticky tires, all of this right here is not needed. Let's go down to my map that I made for my car, which works quite well. Take a look at that. Look at how much different this is. I'm at 100% clamp load here when I launch. When I take off from 0 to, let's see what we have here, 24, to 60 kilometers an hour, I have some ETS action, and then beyond that, it's 0. I'm fully rear-wheel drive after this because I don't need anything up here. At speed, the car doesn't have enough power to blow the rear tires off. Nothing's going to happen. So why have that drivetrain loss and all of that additional friction and wear on both the tires and the ETS by having to do something up here? Completely unnecessary. So if I had a car with more power, let's say a car with USMs, this 100 would probably come out to these next two cells here, and then I'd probably knock it down to maybe 75, 50 from there. So the more power your car will make, the more this is going to shift over. So, we go back to map 4 here, the map that it came with. I mean, this is something for like a 7-second car or something. 99% of us don't need anything this aggressive. And, up here during normal cruising and normal throttle, look at that, we're still around 20, 30, 40% clamp load on this. So when I'm on the interstate driving around, I've got unnecessary ETS action here, where the ETS frictions are generating, friction, or generating heat, and my tires are struggling because the ETS is trying to fight the tires to try to get, equalize the speed. So, all of this is very bad. For a guy that rebuilds ETS units or rebuilds these transmissions, like all of this right here is really, really bad. I don't like seeing that. So, go back to my map 2 here. Again, completely unnecessary for me to have any action here. Now, the reason they did that is to be very safe. They don't know what power the car is making, what kind of person is driving it, and I have to say something else here. You have to be very careful with this. You can easily wreck your car if you have this, cutting off too early and your rear wheel drive too early and you start spinning the tires at the wrong time and you're not aware of what your car is doing. You can easily lose control and wreck the car. So do this at your own risk. I don't want to hear anybody griping at me as they try to figure this out and learn how to set it up for their car. If they burn up their ETS, I don't want to see any hate messages on Facebook that, hey, I burned up my ETS, Jack sucks, blah. It's just stupid. Just don't be an idiot. If you're going to try to figure this out on your own, it's going to cost you. Education costs money for a reason. So, you may burn up your ETS, you may burn up your tires. If you really go nuts with this, you may end up wrecking the car. So just be really, really careful. Be very conservative. Maybe keep all this all the way through here, 25% for now as you figure it out, and then slowly take it away as you get a better feel for the car. And, to do this, it would have to be done by someone who has a very, very good feel of what the car is doing. And that could probably actually log wheel spin as well, because you want to keep wheel spin to a minimum to not burn up the ETS. And that's what I did here. And this is the map that I came up with. It's pretty crazy. I couldn't believe that it would be 0 all the way through here. Now during normal highway driving around this area, you can see it's at 0. So I'm not going to wear out my tires. I'm not going to wear out my ETS. Everything's basically just sitting there. So this is actually what it took for me to do this. Now if I go to my road race map, which is my map 3, you can see that, I'm not highway driving on my road race map. I'm, wide open throttle and trying to, run the car around each lap as fast as I can. So to make the car a little bit more predictable, in these areas where I had 0 before on my street map, I've got a little bit of ETS action going on here. So I got a better, basically better reaction out of the car. The car is not so, it's not going to oversteer at higher speeds here. It's going to be a little bit more controllable. But, the meat of it is still the same. It's just up here, I have a little bit more action. And another great thing about this controller is it also has ETS action for braking. So this is brake percent from the brake pedal, and this is speed. So the ETS will actually work in the opposite direction for braking, which could be very beneficial. So if I'm under heavy braking, I actually have it at 100% ETS action, because with my brakes, I have some pretty beefy racing brakes in the front, but my brakes in the back are still stock. They're pretty weak. So to get a better balance out of a car under heavy braking, I put it at 100% ETS action here, so it feels more balanced under heavy braking. I don't have the ABS clicking on me because the front wheels are trying to lock up and the rears are just doing nothing. This helps spread the load of the braking system out as I brake. So one more thing here before we start driving and looking at all this stuff is this area right here. You saw on a previous map, it was all hundreds through here. Right here on my street map, this is what I call the fun zone, where you see all the 25s. I have less ETS action here because I like to, if I'm in a long sweeping turn, if I let off the throttle a little bit, I'm still going to have some pretty decent torque in this area, and it'll help the car drift out a little bit and have more fun with it. So, this is kind of like my old Porsche 911 map here, where, separates the men from the boys here. You're still on boost, you're off throttle a little bit, you're going to drift a little bit, but if you let off, you're going to lose it and wreck the shit out of the car. You got to hit it, and when you go up to 100% clamp load, the car will straighten out and take off. So at some of the hairpin turns, around my area, around my house in the mountains, I like to give it just a little bit of throttle through the hairpin turn, drift it out a little bit. Then when I go wide open throttle, it's 100%, the car straightens out and just takes off. So it's kind of like a fun area there that you can play with if you like to do some funky things to the car around the turns. So to test these maps, we'll go ahead and make sure we're on map 2 here, which we are. That's my street map. So I'm going to do the best I can here, not to be an idiot while I drive, and show you what's going on. So if we watch the torque split gauge, it can give us a lot of information as to what the car is doing. You can see I'm at 0, right? In the map, I'm at 0 through here, so there's no scuffing when I'm turning, especially in parking lots. No problems at all. Now, I was under braking there, so it went up a little bit when I was braking, but that's about it. So see, it's 0 the whole time. So what's really nice about this is that I'm not wearing out my ETS, I'm not wearing my NT01 tires out by just cruising around normally. And why do I need full all-wheel drive action when I'm just driving around like this? It's completely unnecessary. You're just wearing things out. So, factory or the map that these things came with are not very good. Now, if you watch the accelerator pedal, which is the top center of my center console screen there, I'm still at low speed. If I floor it, you see how the all-wheel drive torque split gauge went all the way up. It's because I was actually hitting the cell where I had a bit more aggressive ETS action. As I gave it more throttle, it'll go up. So let's see, let's put it in manual mode here. So even something like rolling launch. So still no tire wear, not doing anything stupid here. So rolling launch, hold the cancel button. So it held all the way through that, no wheel spin, didn't blow the tires off. It's doing exactly what it's supposed to do, and I have exactly the traction I need to allow the car to perform well on the street. Virtually no tire spin, no drama. That's the way it should be. Again, my center display under my tach is in kilometers an hour. But that's about it. To make sure that you're not going to do anything unexpected as far as the ETS action is concerned, do a rolling launch. Like in second gear here, I get up to enough speed where I virtually have no ETS action at all. Like I floor it, there's nothing there. So is that safe? Am I going to blow the tires off, in that manner? And the best way to check that is just to do a rolling launch, see if it blows the tires off. Another thing to keep in mind is when you're in, when you're in a pretty aggressive turn, and let's say you're doing like a turn at 1G, and you hit the gas and you start to put power to the tires are under a completely different load there than I am going in a straight line right now. So you may have to make some adjustments to the cells, in your map here, like I did. I don't know if you remember looking at the road race map I had. You may have to make some adjustments to allow for more ETS action at higher speeds, so you don't end up just drifting the whole darn course the whole time. So getting to a main road here. I'm in second gear, so I have really good grip, so there's no need for any ETS action here at higher speed, and I'm going to prove that. So rolling launch, full boost, so nothing really happened there. Like no drama, no wheel spin, because I have the grip. Since I have the grip, I don't need the ETS to be working its ass off all the way through the gear and burn itself up. There's just no reason for that. So anyway, I hope that makes sense. I hope that helps people out when they're trying to figure this out. If you have any questions, just feel free to ask. Please visit us on the DCT Facebook group, and or at sales@jackstransmissions.com. Thanks.